Well, good morning, good afternoon, good evening, depending on when you may be watching this. I'm Jamie Mueller, and I serve as the Research Integrity Officer for Purdue University. This video is going to talk a little bit about reproducibility in science and the challenges we have as researchers and as scholars in our various fields of dealing with the issue of reproducibility and the perception it may cause within the general public about our research, but as well as some of the struggles that we have as individual scientists. As is my typical approach, I've included the shared research values that, again, every video that I pretty much record related to RCR, I keep these shared values in front of us. And again, as a reminder, the whole point of, when we look at things like accuracy, efficiency, objectivity, trustworthiness, and integrity, those basically create our reputation as scholars or as researchers. And, one of the most critical things is the thing that I know about reputation is it's much based upon perception as it is in reality. And so we have to protect these elements, these shared values with everything we have as scholars. So given that preamble, let's talk a little bit about reproducibility in science. And so, kind of the assumptions we have about science is that what we find, we hope is universal or can be applied generally or to be generalized. We hope that there's some open sharing because many of us as scholars in our various fields are struggling with some of the same issues or dealing with some of the same things. And so oftentimes we perceive ourselves as researchers as, being open and sharing and trying to collectively solve global challenges and world problems. We espouse the idea of disinterestedness, that is, not being motivated by self-interest and such, but instead being motivated by knowledge and discovery and propelling our fields forward. And then lastly, we consider ourselves organized skeptics. That is, we are supposed to espouse, and I think we do, considering all new evidence, even if it causes us to rethink or challenge prior findings of our own. And so when we talk about research, these are the things that we're talking about. You can kind of, on the right-hand side of the screen, you can actually see the counter to this, right? So the counter to universalism would be particularism, and secrecy would be the counter to communalism. Self-interest over disinterestedness, and then lastly, organized dogmaticism versus skepticism. So typically these things on the left-hand side are the things we espouse as researchers as a foundational tenet of how we approach science. Now, before we go on, I placed this URL, and hopefully you have access to the PowerPoint so that you can actually listen to it. What I want to encourage you to do before we really get into the meat of this PowerPoint, and this is something that I oftentimes do in my class, is I want you to take a listen to this clip from NPR about the challenges of replicating studies. And I want you to jot down some notes of things that stand out to you and pause this video, listen to it, and then restart this video after you've had a chance to listen to it. So pause right now, go listen to the clip, and come right back. So hopefully you had an opportunity to listen to the clip. So a couple things I want to draw out from this clip that usually comes up in conversations when I use this as a discussion point within class. So as you heard in the article, or in the clip here, 100 psychology experiments, 2/3 didn't replicate, and so they're talking about the challenges of replication. And one of the very first things is, the challenge of, well, maybe it's false. Certainly there are things that could make the original findings of whatever those studies are false. But I think one of the things that it draws out in the clip there are several possible explanations for finding contradictory evidence. And so first of all is just understanding that it's very difficult to perfectly replicate a study from one place to another. We strive for the ideal, but we live in the real, and it's very hard to exactly replicate what the original researcher did. And matter of fact, we deal with things like confounding effects or confounding variables. That is, things that could affect, in the clip it talks about the perception of wine or coffee, right? And its health effects, whether they're positive or negative, and you get conflicting opinions on that. And so we have to deal with the aspect or the idea of confounding variables, things like mediating variables, intervening variables, and there are all kinds of definitions of different confounding variables, but that's certainly one thing. But a second thing is, I think, as scientists, I think one of the most poignant things that comes out in that clip is this idea of uncertainty does not mean untrustworthiness. And I think this is one of the ways in which we as researchers and as scholars, we have to be able to educate the general public about what our findings mean. That when we find something to be significant, it means that that didn't happen by chance alone. It calls upon us or draws upon us to make sure that we're doing proper power analysis so that we're minimizing the chance of making errors. Also, we have to think about, effect size, and that, are we talking about, and when we talk about effect size, I'm talking about magnitude of effect. So if I find something that didn't happen by chance, it has significance. What was the magnitude, or how big was the effect as a result of that? Communicating those things and helping the general public understand that when we find something in research, it's not absolute proof that something is true. What we're trying to do is build a case against the opposite of what we're trying to find, and we are never absolutely certain. Matter of fact, as the clip calls out, oftentimes as scholars, as researchers, we're in the business of creating more uncertainty and more questions. And we're always striving to build a case for something or against something, but we're absolutely never certain, and we never prove anything. And so I think that's part of our job as scholars. Another thing that comes out in this clip is the idea that so often things are not replicated because there's not really, journals don't typically fund, or don't typically publish replications. Grant agencies don't fund replications. As a matter of fact, if you're a PhD or a master's student and I ask you the question, for your dissertation, are you doing replication? More than likely, your answer is probably going to be no. Because oftentimes the contributions that we're trying to make to our fields are expected to be original works. So, but I want to come back to, I think the most poignant statement in this clip is this idea of uncertainty does not mean untrustworthiness. And so I think it's upon us as scholars to make sure that we try to educate the public as to what is untrustworthy versus what is uncertainty, and being real with the results that we find and not overextending or over extrapolating what we found. So hopefully you found that clip entertaining or engaging in an intellectual way. I realize that it's from 2005, so it's a little bit dated, but still I think it poses an interesting question that every scholar, no matter what your field you're in, you're going to deal with replication issues and the questions that it causes. So let's move on. And so the National Academies of Science, I like to refer to them because National Academies of Science, Engineering, Medicine, they're kind of like what I would consider the seminal source as it relates to research and scientific research, particularly in the STEM areas. And so I want to draw upon this idea of reproducibility, replicability, and generalizability. So as you can see on the screen, the National Academies define or make a distinction between reproducibility, replicability, and generalizability. Now, already in this clip, I've used the term generalizability. That is the idea that, when we are doing quantitative research of whatever ilk, our goal is to try to take something in a small, like a sample or whatever, and try to generalize to a larger population. That's kind of our goal in quantitative research. But the National Academies make a distinction between the words reproducibility and replicability, and oftentimes we may use those kind of haphazardly or interchangeably, and as you can see there, they're not. So reproducibility, at least according to the National Academies, is where we're using the exact same data and code, or the exact same setup and everything as the original study. So it's basically synonymous with computational reproducibility. Now, when we're working, like if we're doing bench research or we're doing field research or those kinds of things, reproducibility is challenging because we may not have the exact same data. We may try to approach the study in the exact same way, but therein lies one of the challenges. Replicability is probably more often the case of what we do when we're doing bench research, lab research, or whatever, where we're answering the same scientific question, but we're using new data in most cases, or new computational methods, or new approaches, or new methodology. So you can kind of see the nuances of these terms as the National Academy defines them. And so I wanted to draw your attention to it. Now, the National Academies also talk about, like the clip touched on, what are the key issues that we face when we're talking about reproducibility and replicability? Well, first is the idea of uncertainty, right? And making sure that we communicate not just within our scientific community, but to the public at large, what are the things that cause uncertainty, and that we're not proving something, that we're not absolutely certain on something. There's always a measure of uncertainty, whether that be related to error or something else, but communicating that. Second would be making sure that we communicate the limitations of our research and be real about that. I understand that we're all trying to make, every scientist wants to make a reputation for themselves, a name for themselves, a finding. The clip talks about, the findings we make, we kind of have them as personal possessions. But we also have to be real. We can't overextend or exaggerate our findings, and we have to be real with the limitations. And be specific and say what those limitations are. We should not withhold the potential limitations. Third would be confounding factors, which I've mentioned, confounding variables, which I've mentioned relative to the clip we listened to. And again, they're all different types of confounding variables. I'm not going to get into all the, intervening, mediating, moderating. There are lots of different flavors of confounding variables, and probably in your stats courses or maybe in a methodology course, you'll talk about those different ones. But confounding variables are those things that either we know about or maybe even we don't know about that may be potentially affecting the results in a positive or a negative way. And then lastly would be clarity and completeness, and making sure that, particularly as it relates to our reporting of the studies that we do, that we're clear and that we're complete and concise and precise, I should say, with describing the methodologies and the approaches that we use. So NASM provides some recommendations, and I basically pulled out of their document. So first, making sure that you convey clear, specific, and complete information about any methods, even though it says computational and data products there. I would say any methods and any products, regardless of what kind of research you do. Make sure you provide accurate and appropriate characterization of relevant uncertainties. Again, that's like talking about limitations. It's being real. It's not over-exaggerating. Including clear, specific, and complete descriptions of how the reported result was reached. And this is where sometimes people get caught between, okay, how much can I put in the paper because I have page limits or word limits. If you're going to sacrifice in a paper, conference, journal, whatever, I would encourage you not to sacrifice on the methodology. I'd sacrifice in prior works or in the introduction and trim there. And if all else fails, if you don't have enough space in a journal or a conference to truly give a clear, specific, complete description of what you did, provide it in ancillary material, whether that be an addendum to the journal article, a website, something, but be clear, right? And don't withhold, and don't, you need to fully report the entire methodology. Academic institutions should include training the proper use of statistical analysis and inference. I will say here at Purdue we have something called the Statistical Consulting Service that's offered out of the Math Science building by the Stat department. It's a fully, it's one of the most helpful resources. So at Purdue, at least that's one thing that we provide. And then lastly, making sure that you avoid overstating the implications. In other words, over-exaggerating, overreaching, overestimating, making inferences that are far-reaching or really too far. So I would always encourage to be conservative in communicating the implications of your research. So that kind of summarizes this reproducibility in science lecture. Hopefully you found it engaging. This is something that I think it's more of a contemporary topic within the RCR world, but it's certainly something that every researcher struggles with and will have challenges with, particularly when you make significant findings and let's say it can't be reproduced. This is a common problem, and so we have to find ways to try to improve or make that better. So hopefully you found this engaging and interesting. Thank you for your time today. Bye-bye.